For years, artificial intelligence has been celebrated as the next great leap in human progress. The technology that will think, learn, and build alongside us. But there's one thing even the smartest machines can't escape: physics. And now, that reality is catching up fast. Because the more powerful AI gets, the more electricity it consumes. And today, the very technology shaping the future is straining the energy systems of the present. From Virginia to Texas to Arizona, America's electrical grid is being pushed to its limit by a silent force humming behind the scenes. AI data centers. Every new chatbot, every image generator, every corporate AI engine needs vast warehouses of computers running around the clock, and each one gulps down power like a small city. We're talking about an energy demand so huge, it's beginning to rival the consumption of entire states. And this isn't decades away. It's happening right now. In the past 5 years, the United States has seen an explosion of data center construction. Amazon, Microsoft, Google, and Meta are all racing to expand capacity for AI workloads. NVIDIA's GPUs, the chips that power large language models, are selling out before they even ship. But here's the staggering part. Every new hyperscale data center consumes as much electricity as 50,000 homes. Some of the largest campuses under construction will soon draw a gigawatt of power each, the same as a nuclear reactor. According to grid operators, America's data center electricity use has doubled since 2020 and could triple again by 2030. AI models like ChatGPT and Gemini are fueling demand so fast that utilities simply can't keep up. The grid, once built to handle homes and factories, is now being asked to power an entirely new species of energy consumer, one that never sleeps. And the cracks are showing. In Virginia, the world's largest data center hub, officials have already warned that local grids are maxed out. Some neighborhoods have seen housing projects delayed because so much electricity is being rerouted to data centers. In Texas, energy firms are constructing entire new substations just to feed Amazon's AI operations. And in Arizona, regulators are scrambling to find enough power and water to support dozens of upcoming data campuses. For the first time in history, digital expansion is colliding with physical limits. The US built a cloud for infinite computing, but forgot to build the infrastructure to power it. So why is AI so energy hungry? It comes down to computation intensity. Training one large AI model, like GPT-4 or Gemini, requires thousands of GPUs running non-stop for weeks or even months. That single process can use as much electricity as 5,000 US households consume in an entire year. And once that model is deployed, every query you type, every image generated, every voice response delivered continues to draw power. Unlike ordinary software, AI doesn't rest when you stop using it. It keeps learning, fine-tuning, and processing in the background. All day, every day. That means our digital assistants aren't just smarter than ever. They're also hungrier than ever. Now, big tech knows this problem is unsustainable, and quietly the industry is transforming itself from a collection of software firms into something entirely new: hybrid tech energy companies. Microsoft has signed long-term deals to power its data centers with small modular nuclear reactors, turning clean energy into a competitive advantage. Amazon has become the single largest corporate buyer of renewable energy in the world, investing in solar and wind farms across 20 states. Google is experimenting with AI-managed grids, algorithms that balance electricity usage in real time to reduce strain on the network. Even NVIDIA is working with utility companies to design GPU clusters optimized for energy efficiency, using advanced cooling and voltage control systems. In other words, the companies building the digital future are now also trying to rebuild the power grid that sustains it. But there's a harsh truth. Clean energy can't scale as fast as AI can. Permitting and building new solar farms, wind projects, or nuclear plants takes years, sometimes decades. Meanwhile, demand for AI compute doubles roughly every 18 months. That's a gap technology alone can't close. In the short term, utilities are reviving natural gas plants to meet rising demand, a move that risks undoing years of progress on emissions reduction. Some experts warn that if data center growth continues unchecked, America could miss its 2030 climate goals by a wide margin. And here's the part few are talking about. AI is now competing with people for power. In states like Georgia and Virginia, utilities have paused new residential developments or manufacturing expansions because too much electricity has already been allocated to server farms. The future of AI may literally come at the cost of new homes, schools, and local growth. But necessity breeds innovation, and this energy crunch is sparking breakthroughs. Startups are developing low-power chips that perform AI computations using a fraction of the electricity. Cooling systems that once relied on air are being replaced with liquid immersion setups that recycle waste heat into usable energy. Some companies are even exploring AI on the edge systems, smaller models that run directly on devices instead of cloud data centers, cutting power consumption dramatically. The next phase of the AI race won't be about who has the biggest model. It'll be about who has the smartest, most efficient one. Because from now on, energy is the new currency of innovation. Zoom out, and the stakes couldn't be higher. The US has entered a new kind of arms race, not for chips, but for power capacity. Every company wants to expand its digital empire, but only those with reliable, sustainable energy will be able to scale. The AI revolution was born in software, but its survival depends on infrastructure. Transformers, reactors, power lines, and policies. The next wave of competition won't just play out in Silicon Valley boardrooms. It'll happen in utility meetings, state legislatures, and the control rooms of America's energy grid. Because the truth is, AI doesn't just need smarter code, it needs smarter power. So here's the bottom line. The AI boom has pushed innovation further and faster than anyone expected, but it's also revealed how fragile the system behind it really is. Every prompt you type, every model you train, every digital miracle you witness runs on electricity drawn from a grid that was never designed for this scale. And unless the US modernizes that grid quickly, the next great tech crisis won't come from algorithms, regulations, or hardware shortages. It'll come from a blackout. The machines of the future are ready. Now the question is whether we can keep them running. Because in this new era of AI, the story isn't just about intelligence. It's about power.